Hello and welcome back. This video will start Chapter 8, this is the first section of Chapter 8. And this chapter is all about hypothesis testing. So how would statistics actually go about, or how would you actually go about using statistics to make claims about the real world using experiments, using data? So just a few introductory definitions that I think are fairly straightforward. A hypothesis is just a claim or a statement about a property of a population. So we might hypothesize about the proportion of people that satisfy some constraint, or the mean of some data, or the standard deviation of some data. These are all properties of some population. And a hypothesis test is just going to be a procedure for testing that claim. And this chapter is all about hypothesis tests, so making sure that we know exactly how to analyze whether or not we're correct in our claim about proportions or means or standard deviations or whatever property of a population we're looking at. Please excuse my furnace as it's going off now. So this will be the running example throughout this section. We'll just use this example to sort of describe the process. So a survey asks 1,009 people if they'd be comfortable with drone deliveries, having, say, Amazon, for instance, deliver packages to your house using drones. And the survey found that 54% of those people that were asked would not be comfortable with it. So our question, we want to be able to conclude, can we confidently say that the majority of people, as in, say, maybe this is referring to just people in the US, would the majority of, say, Americans be uncomfortable with drone deliveries? Well, we know out of these 1,009 people, 54% would not be comfortable. So it would be a reasonable guess that 54% of all people, of all, let's say, Americans, would be uncomfortable with this. But how confident are we? So we could, we would be more confident if, say, 90% of people in the survey said that. But 54 is close enough to have that maybe the survey just got unlucky, and we asked a few people that would be uncomfortable with it. So our confidence here is what's being called into question. Is 54% a high enough number so that we can confidently say most, say, people would be uncomfortable with deliveries? And this is what's being called into question in the big picture. We have the question of statistical significance. When we see that 54% of 1,009 people believe something, sure, that's fine, but can we make an assumption about all people? Is 54% high enough to be able to guarantee that over half of all people will feel the same way? So with bigger surveys, we have more confidence. With more extreme numbers, we'll have more confidence. So this is all about the significance of our results. So there's what the book lists as an 8-step process to hypothesis testing. The steps are more or less straightforward, but there is a little bit of terminology that we'll go through. The first step, I think, is just going to be the easiest one, is to identify the claim. So in our example, can we confidently say that the majority of people are uncomfortable with drone deliveries? So we could make a claim that so that the majority of people are uncomfortable with, and I'm running out of space, drone deliveries. So this could be the claim that we could make here. And the second thing is to give it a symbolic form, meaning so that we can write it down using mathematics. So maybe something like this. Maybe P, we use P to represent the proportion of people that are uncomfortable with drone deliveries. And if we're going to say that the majority of people, well, that means that P should be greater than 0.5. So this would be the symbolic form of our claim. And then we need to identify the null hypothesis and the alternative hypothesis. So for the moment, I'll define these on the next page. But for the moment, you should think that these are somehow opposites. And what we'll do is we'll test the null hypothesis. So the null hypothesis is going to be a claim, and at the end of our procedure, at the end of our hypothesis test, we'll be able to say, have we supported the null hypothesis, or have we disproven it? Can we reject the null hypothesis? The alternative hypothesis would be what we would use if the null hypothesis is rejected. These are somehow opposites. So I'll come to this more in a second. But in order to talk about whether or not we can accept a hypothesis or not, we need to know the significance level. How confident do we need to be before I can say, yes, we can reject this hypothesis? So this is defining how confident we want to be in our answer. We have to identify our test statistic. So this could be something like a proportion. Like identifying what sort of thing are we looking at? Are we looking at proportions? Are we looking at means? Are we looking at standard deviations? And once we know this, we can look at these test statistics. We can look at the distributions for these statistics. So these are the sorts of things that we will need to know what we're looking at. And then once we know this, we can go down one of two routes. We can either look at the p-values for the test statistic, and we can use those to either reject the null hypothesis or more or less support the null hypothesis, or we can use critical values. And these are slightly different. With the critical values, again, we can use that to either reject the null hypothesis or fail to reject the null hypothesis. And after doing all of this, in this last step, we either say the null hypothesis is false, or we say we can't say that it's false. So we state the conclusion in non-technical terms. The reason behind this is if you're reading a newspaper, I don't think you'd want to be coming across lots of numbers and lots of technical language. In order to communicate your findings, you'd need to say something in a way that people can understand. So this is just to be able to communicate mathematics clearly. So let's make some more definitions here. So what's the difference between a null hypothesis and an alternative hypothesis? So the null hypothesis is a statement that a parameter, for instance, a proportion or a mean or standard deviation, is equal to a value. So a null hypothesis is always going to be something of the form, this parameter equals this value. The alternative hypothesis, on the other hand, is a statement that the parameter is simply going to be different from a value. And there's different ways to say that something is different. So we could say that the parameter is greater than some number. We could say that the parameter is going to be less than some number. Or we could simply say that the parameter is not equal to that value. So an alternative hypothesis is always going to include either a greater than, a less than, or a not equal to. Whereas a null hypothesis will always include the equals to sign. So this is all the differences. And then we can give these names. The null hypothesis is always written H sub 0, as in H naught is how you'd read this. The alternative hypothesis is usually written H sub 1, as in H1. But sometimes people like to go, oh, it's the alternative hypothesis. It starts with A, so they call it HA, either little a or capital A. I think the book tends to use H0 and H1. So H0, the null hypothesis, will always have an equal sign. The alternative hypothesis will always have a greater than or a less than or a not equal to sign. So if we look back through our example, our claim in our example is that more than half of people are uncomfortable with drone deliveries. Okay, so we established this fact, but we can also write this using symbols in a more mathematical, more precise way. So if I say that P is going to be the proportion of people that are uncomfortable with drone deliveries, this is the claim written with more technical writing. So we're saying that P is greater than 0.5, as in the proportion of people that are uncomfortable with drones is greater than 50%. And one nice thing to notice here is that if P is not greater than 0.5, the opposite of this is going to be that P is less than or equal to 0.5. So if the proportion of people is not bigger than 50, it's either going to be 50 or smaller. It's either going to be less than or equal to 50%. So this is just setting up the null and alternative hypotheses. So for the null hypothesis in this scenario, we want to say that the proportion is going to be equal to some number. And again, what number are we referring to is going to be 0.5. Whereas the alternative hypothesis, typically we choose the claim that we are making to be the alternative hypothesis. So the alternative hypothesis, H1, is going to be P is greater than 0.5. So again, what we notice is that the null hypothesis has an equals to sign in it. The alternative hypothesis either has a greater than, less than, or not equal to sign in it. And whenever we want to support a claim, so if we were trying to prove that P is greater than 0.5, we want it to be the alternative hypothesis. The alternative hypothesis is the one that you are supporting, the one that you believe to be true. The null hypothesis is the one that you hope your study shows is wrong. So if we were conducting this experiment, conducting this study, we would say, oh, P is equal to 0.5, and then we'd go through the steps of saying, this is not true. Therefore, our alternative hypothesis is true. Next up, we need to choose a significance level. And this, the book has thrown around the word significance level and significance a lot, so let's give this an exact definition. So the significance level alpha in a hypothesis test is the probability that you reject the null hypothesis when it was actually true. So this would be a mistake in our work. If we said H0 is false, but it was actually true, this is a type of error, and we'll look at this in a little bit. This is called a type 1 error. And we don't want to make errors. We want, so exactly that. We don't want to make errors. So we want the probability that we make an error to be small. So we will choose an alpha that's small. And by choosing a small alpha, we're more confident that if we do reject the null hypothesis, that it was actually false, that we were correct. So alpha here is usually going to be either 10%, so as a decimal 0.1, 0.05, or 0.01. 0.05 tends to be the one that's most common in the literature, in statistics, but it's by no means the only one. For instance, things that are more sensitive, more important, say like in medical research, testing drugs, maybe we would want 0.01 or even smaller to make sure that we don't have errors. The probability that the error occurs is going to be a lot smaller.